All right, so welcome, Dael. And it's really exciting to have a discussion around AI, how companies use, and what you see. You have a very wide net on the EMEA market. So let's start by, can you tell a bit about your job and what you do as the field CTO for Databricks?
Great to be here and awesome to see you. You and I have known each other a very long time, and I am very worried about how this is going to go off the rails, but very happy to be here. And I'm actually kind of glad this has turned into a podcast. So my role is EMEA field CTO. We don't have an army of field CTOs. We actually have 3, I think, of us in the company total. I'm the only one in EMEA. And we have a chief AI officer, Maria. And what I do is I focus on big, gnarly, complex problems, complex domains. Every year there's something subtly different that emerges. Last year was very much centered around building like new applications. This year is centered around AI adoption and figuring out how to stabilize those applications in production. So it's a very tacit role, but like typically I work with loads of executives. A lot of it's executive education. My background is I'm a biochemist. And it actually makes a lot of sense when you kind of actually explain how it works. Like I did a lot of wet lab work, which is cool. You're kind of working with DNA, you're working with RNA, you're working with proteins, you're working with cells. You're working with different bounded contexts of complex systems that just happen to live inside us or live inside plants and other things. I used to do a lot of viral studies, spike proteins, stuff like that. So system to system is kind of my thing, complex system theory. And a lot of that then traversed into simulatory work because you want to accelerate drug discovery, industrial waste, bioremediation, stuff like that. So you work with data, very, very big data.
Before it was like big data.
Even big by today's standards. Like even when I speak to pharmaceutical companies today, this is like still a challenge because of the just sheer gravity of these, the density of what you find in these data sets. Because remember, you're studying something that's times 10 to the minus 10 small. Even by today's standards, massively hard. And you're running simulations and you always had compute constraints, like in the 2000s. You were building things with Python frameworks. So like when I describe what I did and you think about what we do
Sounds
today,
very like the present.
It's not that dissimilar. The only difference is time compression. Like something that took me 45 to 185 days, today it could be like 4 hours to maybe a week. So there's been a rampant improvement in compute, in storage, in parallel processing, distributed networks, yada, yada, yada. But I've been working on these things as a practitioner for years, but also sort of traversed up the organizations. I've managed large teams. I've sort of also observed the management overhead of like how people work. You and I actually talked about this when I arrived. The alignment overhead, the coordination overhead. Coordination overhead is the silent killer of every company. Like just getting people to kind of move in the same line. It's hard enough doing it when you're the coach of like a football team. Imagine what it looks like when you're the CEO of a company of 11,000 people. Even more surprising in a role like mine, where you're the CTO of like an entire region and no one reports to you. So you effectively have to lead through persuasion. And then you have a network of partners. Like we have, I don't know, something like 1,200 consulting and SI partners globally. We have about 1,500 ISV partners globally.
Probably not that far, even in Europe, actually.
And it effectively takes you to a really fascinating, complex problem. And I love those puzzles. And then you're trying to figure out, how does AI fit into the story? How does new tech fit into the story? And how do you take the old tech and move it to the new tech and keep the thing moving and not break the thing and not have planes falling out of the sky?
Yeah.
So
I really love that you mentioned that you started out in biology, but you also said in an organization and then helped organizations. And then now you are partially on the vendor side, but you're also working very closely with the companies who are trying to use the technology of today. So your career path across these different roles, what is the perspective it gave you about the technology, how we use today?
In my career, I've been the head of engineering in a sort of not quite a vendor company, more like an OEM. I suppose we were a vendor, an OEM for like basically building auto provisioning business logic on top of telephony networks. Okay.
Yeah.
I was an engineering team that was, I don't know, it was started at 5 people and we scaled to about 250 during my tenure. That meant trying to figure out automation. We had a lot of QAs. We needed to reduce bug counts.
Yeah.
We needed to fix inefficiencies. And that was kind of cool because, I was also on the customer side for many years. So, my career started building underwriting mainframes. And then I moved into building order management and supply chain mainframes. Okay, that was in the 90s. That was for a big insurance company and then a big retailer. And some of it was mainframe, some of it was starting in the early days of kind of building Unix boxes and building Java wrappers. And you started to realize the intricacies of the complexity of legacy tech.
Yeah.
So most people think, oh, we'll just move the mainframe. What you don't realize is there's these layers that have been kind of thrown on top. You couldn't replace the mainframe, so you built on top of the mainframe. So the mainframe still has probably in a lot of cases SOAP interfaces, which then link in, and I built a lot of those. So that was like when I worked for a major bank here in the UK, who happened to actually be my bank. And I think that there's systems that I put in place in 2000, 2001, and now you're going to go look me up on LinkedIn and you'll find them. And I think they're still there. So my appreciation of what legacy really means is sort of one aspect. If you don't really get it, if you don't really get what went into building this, you can't get what goes into replacing it or modernizing it. So that's a huge empathy and kind of lived experience that's very hard to emulate.
Yeah.
So that's number one. Number two, I've spent significant chunks of my career on the consulting side. Not significant, but probably, I don't know, in total, maybe 8 years of my career was in various consulting capacities. 2 of them, the last sort of 6 years of it was as an executive in a consultancy. So you're running a big P&L, you have a huge practice, you're trying to ramp up people, you're trying to deliver, you're living and breathing by maintaining a margin and not ending up with negative cost of completion. You're living and breathing through kind of economics of human labor, but in a knowledge work kind of complex implementation approach. If you couple that to then running a product engineering team, okay, those are 2 very different methodologies. And I don't think many people appreciate this. Lots of people ask, why do consultancies not build their own products? Well, because the sort of P&L fights against it.
Yeah.
I used to have this. I'd build something really cool, almost like product mindset inside like one of the big GSIs. And then someone would come along with a major deal and sell my team. And then I had to start again. Yeah. I had code, but I had the whole human ramp up. So that appreciation for how partners work, how independent software vendors work, how enterprises work, the legacy enterprises have, doing business-to-business deals. I was part of a major deal between a tour operator and a travel kind of online digital native. I've never seen anything so more ridiculous in my life. So that was like months of going through figuring out how to wire two fundamentally different yet behemoth companies together.
Yeah.
Okay. And that lived experience teaches you like about what the meaning of an ecosystem in an organizational context means.
Yeah.
Now, obviously, being a biologist, you really fundamentally understand the ecosystems of living systems, how at a fundamental building block level, the food supply chain actually works.
And some of it is translatable, right?
It's
the models.
Totally translatable. And I'm going to kind of end on a point there where why I'm so morbidly obsessed with open source and why I love the company I belong to is all of the most complex problems in the world are built with open source tools, right?
Yeah.
Because it has to be things that are interoperable. And if you look at biomimicry, so if you actually just emulate what happens in biology, we use the exact same amino acids and absorb them that plants produce. Not completely exact. Some things we have to produce ourselves, some things we can get from other things, but they're transferable. They're interoperable. DNA is interoperable between us and, well, that's plastic, but like I think there's an actual plant on top of you. So that's why we can eat plants and that's why we can eat animals, because we can kind of decompose, reassemble, recompose.
Yeah.
And if you were to emulate the average company today, like even a large multinational, even a digital native, they're probably more akin to a sloth than they are to like a cheetah or like a high-performing organism. And you can kind of see the inefficiencies. So that's what I see when I kind of look at the flow of the system. I see the inefficiencies. Yeah. It's almost like innate. It's weird.
Yeah, and I love that. I love that comparison because when I look at seemingly technical problems, I often see non-technical solutions behind, because the problem is not really a technology, but often we focus on that. And when I was looking at how companies use AI, which is a broad category right now, there is a McKinsey study which says 88% of companies report they use AI, at least in one business function. So there's one qualification there already. But they also say that only 1% think that they are mature. So there is this huge gap, seemingly huge gap between. So the sloth comparison is probably true, because when I read this, I initially thought that's not my experience. Probably because of your scientific background, you have really good way to think in structures and systems. So what's your mental model when you think about the maturity of these organisms, especially around how they adopt AI or technology? And this is AI, but I think it's translatable to other new technologies in general.
So when I look at what people meaning is actually quite an important thing, right? So when they say AI adoption, for the most part, they're talking about an individual, that is literally just using something AI related that maybe answers questions or they talk to it.
The classical chatbot.
Very simple in the terms of what AI can do in a kind of broad strokes application kind of mechanism. What they're using it for is, akin to something insanely simple.
Yeah.
Okay. But that doesn't mean they're not using it.
Yeah.
So hence the large number. From a kind of maturity perspective, I think maturity almost has to be gauged on a spectrum. And I actually think they're fairly right, 1%. So I'll give you a counter statistic. Yeah. Well, not a counter, a kind of reinforcing statistic, right? So loads of companies are talking about AI getting to production. Now, that's not bought AI, that's built AI.
Yeah.
Okay. So we build systems and it's really hard. And like, you've got all these studies. There's the one that everyone has gone mental about, the MIT 95% of use cases don't go to production, right? I was at a dinner last night, one of the analyst companies, and the number's like 80% apparently. Now, what's interesting is let's assume the number's 80%, right? So they go to production. Then our own analysis shows us, because we're a consumption company, so I love evidence, and I have this like insane amount of usage behavior that I can analyze. And our own evidence shows us that of the 20% that makes it to production, well, let's say it's 10% that make it to production, because I think that's kind of averages between the two studies. Of the 10% that make it to production, 30% stay in production. Okay.
So the mortality is even further.
Correct. So like we're not measuring that yet as a collective.
Yeah.
But I would imagine that if you're a CEO or CIO, like I don't know who responded to this study at McKinsey, probably CEOs, because it's McKinsey.
Yeah.
You're seeing things go to production, and you're seeing only 30% stayed in production. So that's of the 10% that went to production. Further studies that we've done has shown us that the 4 times greater likelihood is that production is a tech company. So they're not an enterprise who sell like, adhesives or they're a retailer or whatever. It's more likely that they're a kind of technology company. So 4 times more likely, meaning that number of stay in production is like a rounding error. It's like tiny. And it's probably they've built something that does insane amounts of document analysis, which, to be honest, is a superpower use case. But in terms of maturity, we would kind of classify that as like, hello world.
Yeah.
It's like, well done. You've figured out how to build something that is immensely useful for your company and probably helps the collective rather than the individuals be more productive. But it's kind of level 1 on the spectrum.
It almost tells me that the dormant possibility for value creation is still enormous.
Oh, it's excessive.
90% what we see already, which I think Anthropic actually released a report of their model usage, and most of it was software engineering. I don't remember the exact number, but I think it was like 80% software engineering. And software engineering has some attributes like structured, a lot of training data, pretty good way to prove that something is done. But I think there are also other areas where the same attributes apply. And that's still a large pool of use cases that's still there. And so the number that you mentioned, how do you think about what are the early signs that a company will fall into one bracket and another? I mean, you mentioned technology, being technology is a good, but what are the others?
So technology companies are moving 4 times faster than any other cohort, hands down. Probably distorted, to your point, by software engineers and the fact that a lot of their company is driven by code. Ironically, they are also the companies that are taking the biggest market hammering.
Nowadays,
which I truly find as it's actually a fascinating indicator, because it's more an indication of recalibration of a sector. So if you buy equities or bonds are very safe. SaaS was very safe.
Yeah.
If it was a SaaS company that went public, it was a pretty safe bet that you're going to make money year on year. You might not get like excessive growth, but you're still going to get growth. They have healthy gross margins. So all that's happening is that they're just getting revalued because they don't have that kind of long-term appeal anymore. And that's a very simple kind of recalibration of a system. Yeah. Doesn't mean these companies are disappearing. So like there's a lot of, whoa, SaaS is dead. It's not. It's just recalibrating, right? And there are SaaS companies that are adopting AI internally. And that's where you're sort of seeing this distorted number of 4 times faster. They also have a lot of code that effectively gives we talked before we started this about context. So like a very large code base basically creates a really interesting context awareness that AI can kind of use. So as a company, why software engineers are doing so well is you can feed in the GitHub repo for your company, your product stack, and it recalibrates to that.
Yeah.
In a similar way, you could probably do the same thing with the finance semantics if you could get it out of the system that it sits in. GitHub, very easy to access. Some of the semantics that's sitting in some of your BI systems, a little bit harder to access, very proprietary, very locked. If it's sitting in a system of record, really hard. It's like penetrating concrete. If it's sitting in a mainframe, it's all compiled. So figuring out what it does is even more tricky. So like that's a good way of kind of profiling why the adoption's faster on the one side, because it's the accessibility is a little bit easier, and also the skill base that they have. They're like, even if you're not an AI engineer, the ramp up to AI engineer, if you are an engineer, is pretty fast if you can get your head out of your arse. The problem with software engineers that we observe is how many of them, the older ones specifically, are very reluctant to use these tools.
Yeah.
There's a few that kind of just go mad. They see this as a total unlock.
Yeah.
Okay. But they're more the non-linear thinkers, the ones that kind of look up and go, hey, this will... And actually, to be honest, they normally were the lazy ones.
Yeah.
Yeah,
they found ways.
Lazy engineers and hackers are probably the most likely to move really fast. And then you have the very disciplined, very methodical, that they have to recalibrate their entire human flow, the habits, the way they work, the kind of, I have my coffee at this time and then I run this and then I do this. So people love routine. And that's why there's always this contrast between what AI can do and then what humans habitually have got used to. And we call that change management, right? But this is like at a completely different level of speed.
If I think that through, that leads to the conclusion that the kind of teams, individuals made of a team, but the teams often have a micro culture, so they are somewhat similar. The teams who were successful through discipline are now left behind because the others are using the tools that have nonlinear returns, and then they will move faster and they are less reluctant to try and innovate because they have the positive feedback.
So right now, I think we're at the stage, and it's a very good sort of analogy. I think that the most productive engineers are the rebels. They and actually we'll slowly get to a world, and actually what's it's quite funny, what's being produced right now is a lot of AI software slop. So we talk about AI slop, but actually in the software context, you suddenly producing, like a company's suddenly producing 400 CRMs because everybody now wants to vibe code a CRM. And to be honest, it's kind of a cool exercise to do because you get a whole lot of learning out of it. Does the thing help the individual? Yes, it does. So you will have a relative spectrum of like power users who are using these things every day and they're generating a whole lot of tokens and ironically hit budget limits and then kind of get blocked and then have to go through a very manual process, normally on a spreadsheet, to go and reapply for more budget, or they have to wait 4 days for the budget to reset. So that is a very interesting kind of new world meets old world kind of distortion. But then there's the teams, and you've got very able sort of principal engineers that are going, how do I make this cohesive so that the team become faster? I think that's only just starting to emerge, where somebody really sensible is creating repeatable frameworks. Now, we went through this. So like I outlined in the beginning, my first job was building an underwriting system on a mainframe. Okay. There was no real team in that. We were programmers. We programmed. We didn't have GitHub repos. We didn't have automated testing. We didn't have any of that stuff. You worked in your area and the other person worked in their area, and you tried not to stand on each other. You were very, very individual. And that was the build part of waterfall.
Yeah.
And waterfall was very 80% design and build, and then you furiously tested at the end and then implemented because you had a deadline. And those sort of projects were hilarious to work in. In the 2000s, we went through the automation waves, as a consequence.
Starting of RPO.
Yeah, you've got like kind of the Agile Manifesto gets signed, sort of. I mean, I think that was actually in the 90s, but it took a while for that to ripple through the industry.
Yeah.
So around about, I don't know, mid 2000s, like engineers you had the emergence of LAMP stack, you had the emergence of like Linux sort of becoming a first party sort of big user community. You had a whole system of different automation tooling. You had the Hudsons, you had the which became Jenkins, you had, Chef and Puppet crept in, but that was actually quite late 90s. You had all this kind of bubble of innovation that happened sort of .com post and needed to stabilize. And there was a whole lot of automation cycles before we stabilized onto repeatable frameworks. We didn't even use Git. Git wasn't invented until probably late 2000s.
And the adaptation was actually pretty slow because a lot of companies stuck on SVN
and
the others.
Yeah, exactly. So we went through these kind of iterations, that moved from no repo to SVN repo to Git was something that took quite a long time. I mean, I would say if you did the analysis, you're probably looking at about 15 years of as an adoption cycle. Now, obviously, we are incredibly impatient today in the 2020s, and we're expecting ROI in 3 years of a probabilistic system that has to be embedded in a very old system that's going to hit its head. I'm vibe coding 1 minute, hit a budget limit, I'm now on a spreadsheet, to request more budget, and I have to wait for the approvals to manually be reviewed. Like that is the lived experience of many engineers, where the old world, new world hits itself. And remember, even when we went through all of that engineering, we just wrapped the old world. We did not replace it. AS400s still have growth every year.
You mean still growing?
Yes. I mean, not single digit.
I did not expect that.
But people still buy AS400s.
And that's actually a very interesting point. And you mentioned that sometimes software engineers are the ones who are reluctant to use. And that was also very surprising for me because in my discussions, I see two types of reaction. One is a discussion about why it's not working. And if you look at even just AI in software engineering, you can probably list a lot of reasons why it's challenging or difficult or things that we did not figure out. And I also see a very different type of discussion where they try to find solutions, the innovators that you mentioned. And the people who will find the solutions are from the second group because they are already working on some of these. And it will take time. And I think a lot of people try to find the data to back up the AI production. And maybe now we see that, but even if we don't see that, it's a fascinating parallel to the Industrial Revolution because productivity data did not show a change for almost a decade. And then there were a lot of studies why it happened, why such a fundamental change did not show up in a year or in 2 years. And the reason was that a lot of systems had to catch up with the change. In the Industrial Revolution's case, it was education, reskilling, so the finance, the capital system. Factories did not change the machines immediately, so there was a delay there. And also the infrastructure did not catch up. The railways, so even if the productivity grew, they couldn't transport it out, so you couldn't see that on a GDP level aggregation. And that's also, I think it might be very similar in today's case based on what you say.
It totally is. Like, think about it, right? AI needs to run on GPUs. Do we have enough?
Based on the price.
Yeah. AI must be cost prohibitive. Like, we haven't figured out, I mean, it's happening. We're figuring out how to shrink them and make them incredibly useful. So LLM becomes small language model. So we are getting a little bit better at those techniques. We're getting better at techniques around analyzing what's going on inside the machine. We're getting better at analyzing how to build evals to sort of maintain the machine. I'll draw a parallel, right, for you. A transformer network is a probabilistic system. A protein is also a probabilistic system, right? Both are probabilistic in nature. They have structure, both do. In biotech, when we invest in building a new drug, we give it about a 13-year horizon. Okay, it's very sort of long horizon. We're asking for ROI when ChatGPT only kind of kicked the world into gear around a month after my 3-year-old was born.
Yeah.
Okay. And our expectation is that this is measurable already. Yet we have a counterpoint where we quite acceptably throw money at something and know the likelihood of failure is great. Okay, we do the same thing in venture.
Yeah, that's the example that came to my mind.
So you have startups. So I think we're measuring it on the wrong metric.
Level.
Yeah, so measurement is wrong. I think it's kind of, you almost have to think about how the I factors into this, so the return on investment. So it's basically like, how do you measure the return on investment of a seed round startup versus a Series A, versus a Series B, versus a Series C? What's the time horizon that you allow for? What's the growth you allow for? What's the productivity of that group? I mean, you're the CEO of a company. Like, in the beginning, it was chaos, right? You were the janitor and you were the CEO.
Yeah.
So, and measuring anything was almost impossible. We're a 13-year-old company and we're still trying to figure out how to measure stuff.
Yeah.
Like, measuring is very, very hard. And measurements change over time. You know, you kind of go from measuring 2 or 3 things to measuring like 72 things to measuring like 50 things and you just bounce around, and like you kind of have to recalibrate because you're not entirely sure what's the right thing to measure. Measuring productivity of humans and teams and departments and entire business functions as a consequence of AI injection into their workflow. Yeah, we're very immature in that still. Yeah. And I think there's almost like an impatience in the market about it. We also have a recalibration, right? So a good counterexample of this is like when we started to buy infrastructure, we had to shift our finance brain from a CapEx system to an OpEx system of how IT would run. Then we started to buy consumption software as opposed to per seat license software, and we had to go through a second recalibration. Now we have token usage.
It's a whole new unit economics.
It's a whole new thing. And we have no idea how to cache it. So a cool little technique I saw the other day is like if you measured just the incremental token usage where you're just hammering a model company API, you can hit $400, $500 really easily. But if you cache the hell out of it, you can actually throttle that down to around about, $97, which would have typically cost you $500 and something. Like in one session where you're kind of working on building something. Okay, so I'm talking about software people building something. That is already a step change. But it's already teaching us that there's some infrastructure components that we hadn't considered, like how do we model our telemetry? Now, the AI companies, not the foundation model AI companies, the more AI native type of wrapper companies, like applications, like the Cursors of the world, the Lovables of the world, they're learning this really fast. Telemetry is massively important. And what I mean by telemetry is like the trace of what the models do as a consequence of like work, what the systems do, because models are singular, and actually we're moving more to kind of system thinking, which is akin to building applications. But these applications are quite different to anything we've built before, because the applications we used to have were very static. They kind of have very static workflow, static processes. And this is a key word that like nobody's really sort of taking into account. So one of my favorite papers from last year was written by Ethan Mollick. It was a sort of analogy on, like, he said the garbage can versus the bitter truth. Okay, so the garbage can theory is based on Ruth Ann Hussing's work, where she analyzed processes in a company.
Yeah.
And then she analyzed the actual activities that it took to do work.
Okay.
So let's assume that a process is 6 stages to go from identification to finished, or at least to live. Okay. Underneath that, actually, if you model it out, and this is why Celonis is a decacorn, it's about 1,000 activities that take a huge amount of time, and none of that interaction data and that activity data and the event logs and all of that stuff is captured. So we talk about reinvention of process, but we actually don't even know what the process is. We have an oversimplified distortion of the process. Okay. It's a bit like learning the citric acid cycle to figure out how insulin works.
Yeah.
Like, we have an oversimplified distortion of it. If we really knew, there would be no diabetes in the world today. So the analogy is true. We just really, really suck at, complex system analysis. But we're starting to get really good at this with pulling different data points to generate this, and then you fill in gaps. And, airlines do this already with flight trajectories. So it's not like this is an unknown thing. It's just we haven't borrowed from that domain and applied it to this domain. And that's what kind of the spectrum of my job gives me, is I see something over here and I'm like, that could apply there. So that's the garbage can. And I don't think anyone appreciates just how much detail that is. So you often have boards that don't like to get into the detail. Well, guess what? In this world, you have to get into the detail. You have no choice. And this is the advice I typically give to boards, is get into the detail. There is no getting around this. And then the second thing is the bitter truth, which is basically the Richard Sutton paper from 2019. He's the godfather of RL being reinforcement learning. And one of the things he outlined was you have AlphaGo and AlphaZero. So DeepMind creates AlphaGo. AlphaGo is trained on 2,000 years of Go knowledge. AlphaGo beats the world Go champion. AlphaZero learns how to play Go through self-play.
Yeah.
No training. Self-play beats AlphaGo. So the bitter truth is that these things can figure out stuff much faster than we can figure out stuff from 2,000 years of collective knowledge. They're just very good at this. That's both terrifying, but it's also an important lesson in recalibration. Should we be the ones designing the processes, or should we figure out how the process works? And this is why the rebels are doing so well in software engineering, because they're actually non-linear and they kind of think, hey, hang on, let me just see what this thing comes up with.
They seem like don't care about the process that they should stick to.
Yeah.
So they find an easier way to
hackers.
the resolution.
They're hackers.
Yeah.
Another way of framing this is, I'm a foreigner who lives in the British system. I can see the bugs because I come from chaos. And it's basically all it boils, and you can see this with founders. Most founders, very successful founders of the most successful companies of our time, are foreigners to the country in which they live.
Yeah, and that's actually a very interesting aspect, because one of the common problem with larger enterprises is they have such an organizational headwind to move because of all the alignment that we actually discussed, that they are afraid, and I think rightly so, that much more agile newcomers can disrupt, especially now that some of the moats that we've seen, like the software moat, is now not such a big moat anymore because the cost of software is now going down. So you can re-implement something pretty fast. So how should the organizations think about investment to counter that and generally about this seemingly fundamental change in the market?
I think there has to be a kind of first principle thinking approach to your company. Like, what's the purpose of your company, right? And boards do disaster scenario analysis, okay, which is kind of cool, you know. One of the best applications of combining different tools like machine learning, Monte Carlo simulations, stress, agent-based modeling, which is all the kind of AI from the 80s beyond, and applying reasoning agents and some of the newer dialects on top of those, you start to package very good risk applications. Things that were painfully hard to simulate are ridiculously easy to simulate by comparison.
Yeah.
They're still complex and they're still mathematically hard to kind of detect. But you have software engineers that should be building that stuff. And that's where the real kind of practitioner, deep, sort of very top experts should be working. Because that's kind of white space. That's applications we've never had before, right? Risk management systems that can be built very, very quickly. And if they recognize that actually technology is recalibrated too, so you do not need to have source system there, analytics system here. You have this big gap. That gap is irrelevant today.
No, yeah.
If we were to build from first principles using the tech we have today, you have a transactional database working in lockstep with a knowledge bank vector search type database working in lockstep with a time series, and you're using the same pane of glass. Okay, that is a totally doable thing. And I know it's doable because that's our technology. That's what our technology does. We have lake-based, we have lakehouse, and we have vector search. Those three things combined are like a superpower beyond it. And then you have Lakeflow in the background that just, and I didn't want it to kind of go product on this. If I vibe code on top of these tools, my productivity to build applications that were just impossible even 5 years ago, the barriers are gone to do that. So that's where white space comes from. The other thing that's happening is everybody's a SWE. And what I mean by that is, let's assume, as more or less accurate, that there's about 5,000 really hyper-skilled ML researchers on the planet. Okay? Like PhD level, right? And that is a very hard group to tap. And they're getting paid outrageous salaries because of this movement. If we then move to group 2, which are like, you know, you and I probably fit into this group, even though we don't do that job, where you've got real depth in domain and real depth in data science, machine learning, and sort of deep software engineering practitioner. There's probably about 100,000 of us on the planet. If you then move to general software engineers that are very, very good, okay, like very deep system engineering types, maybe you get to 500,000, maybe 1 million at a push. You then get to application engineers, so people who take APIs, take things and build applications on top. Maybe you get to about 5 million of those. So if you kind of bucket the whole group, it's still a very small drop in the ocean compared to how many companies spend a ton of money on tech. And basically it's the size of the resource group of the tech industry. And we got to ignore like certain roles in the tech industry. Yeah. What this movement's done, and it's already an early indication, I had a sales guy build a CRM using Cursor. Okay? Like I mean, it wasn't bad either. I've seen examples where we've done hackathons of totally non-technical people building remarkable technical software. Yeah. Okay, because they have a system brain, you know, And there's lots of people that have system brains out there. You have engineers. They might not be software engineers, but mechanical engineers could pick this up super quickly. I've got a friend who's in construction. He is one of the biggest AI users I've ever seen. Like his usage of it, he uses for interior design. He uses it for hacking his job. He uses it, and he's dyslexic, so he loves it. So he talks to it. So he doesn't write. The accessibility of building software has never been more apparent, which means it's diffusing. In the same way as you needed somebody working in the ground floor, we talked about AS400s before, entering sales stuff into the system until suddenly we had a web browser and everyone could do it straight into a form.
Yeah.
Still a really rubbish pattern because the form is a diffusion of knowledge. So you're condensing stuff. I think we're moving to a world where everybody can build software. So that's great. It diffuses the skill. Everyone will build software because, to be honest, it makes us more productive to build something that's more personalized. But it has to work. So the problem is how do we make it work? And that's basically moving from the waterfall software engineering to the agile software engineering again.
Yeah.
Just with a new tool base.
And with a whole new population.
And a whole new population. So we're probably now moving to a world where we have 100 million people that are going to learn these skills over the next 2 years.
And if we learn something from shadow IT, it's very risky to try to barrier it.
Yeah.
Because they will find a way. Business always finds a way.
So I asked this experiment. When I hit a budget limit, I ran the experiment to see how quickly I could hit a budget limit on AI usage for coding. And I built something really practical and really useful. Like it's seriously interesting. The amount of things I found in the last sort of week or so just by doing this exercise was super fascinating. And then I asked the question, when I hit the budget limit, I went, what do people do? So you have some people that will go and request more budget. You have some people that will wait for the budget to reset. And you have other people that will just use their own tools.
Yeah.
That third group is where chaos reigns. And we've lived this before with SaaS. When business users just used their credit card and bought a CRM because they got frustrated with IT. So this is what's going to happen. Now, one of the most fascinating things is if IT people, is now moving into the business population, and one could argue this has been happening for years already, like take away people's phones, their email, their text message, and everything in a business user context and tell them to do their job.
Yeah.
Like just think about how no one can do their job when AWS had their outage, or when Azure has an outage, or when GCP has an outage. Like no one can do their job in a specific region. You might as well just take the dog for a walk.
Yeah, which a lot of people
So
did.
everyone is a tech person. There's no distinction now between business and IT. This accelerates that diffusion, like in a profound way. So then the question becomes, what does the IT department look like in the future? And we have some early indications of that. So an IT department in a big enterprise is massive, huge people, huge number of people, and a relatively large cost to house all of this heterogeneous, like legacy compounded debt over time. Which hasn't been paid back, so it's going to come wanting. And now you need access to the data, so you have to ask yourself the philosophical question, what do I have there and how do I use it? The next problem that then emerges is you start to profile a digital native. Digital native IT departments are around 2% of their headcount, but about 50% of their cost structure. And that's because technical users are working in business roles. I'm in a business role, but I'm a very technical user. So that's a very different distinction. And then you move to an AI company where you have shrunk the headcount relative to revenue, and you've amplified the AI usage. So it's not just larger tech cost and lower headcount running the tech. So that first wave diffusion happens. You now have the second wave diffusion where it's high tech cost, high token cost, lower headcount.
let me make the question even harder for you, because you mentioned that I know how IT will look like and the cost structure will look like. We talked about the operational model too, and it's clear that trying to bolt AI on top of the old model will not work. So how do you see that the AI native company, or whatever that means, but how the operating model will look like, let's say 3 or 5 years down the line?
I think it's going to go in a similar way to factories. Like, organizations are going to emulate what we saw with factories. You've got to actually go back in time and understand, how did organizations grow to the size they grew? And when I say grow to the size they grew, like just head count.
Yeah.
And you've also got to assume, remember the sloth comment?
Yeah.
They operate like a sloth if you were to compare it to anything in a living system. Yeah. Now, what do I mean by that? I mean the alignment, the coordination that's in a constant flow. Like, human bodies don't need to do that. Like, I don't need to have 15 meetings for my hand to reach out to my cup. Yeah. Okay, so there's immediate flow for my brain to set a signal to my hand. Yeah. That's how organizations need to start thinking, is how do they create that kind of cohesion? So one way that the AI natives seem to be doing, and it's not true of all of them, they are amplifying humans, because there are humans you need, because there is the intersections that exist where it's very, very difficult to operate. But if you look at back office functions and you look at IT departments, which are a effective form of back office function, that could shrink dramatically, which reduces the sort of overhead. It doesn't mean people are redundant. It just means people evolve into different roles.
Yeah.
Okay, so that immediately tells us you're going to have resistance. It's going to be very, very hard to weather that storm.
Yeah.
To be frank, most people can cross-train pretty quickly, because on the flip side of it, we have AI tools that accelerate your learning. I wasn't an expert in agribusiness, 2 years ago. I got a podcast on agribusiness tech, pumped it into Gemini, and then just used it, and suddenly I know what I'm doing.
Tutor.
I use these things as tutors all the time. So education, accessibility to education has never been more profound. It was profound a decade ago when we had Google, like search, but it was hard. Now you have a variety of tools that give you answers really quickly. And if you don't like their tone, you can switch tools.
Yeah.
So there's also options. So adapting, it has never been faster. So why are people not doing it? And it's just human habit. We almost lazy and like routine. So there's an interesting thing where you're going to have people kind of lean into it. And I was listening to somebody actually talk about this, where roles become like this soup of boundaries. Like, there's just no boundaries as to where role A begins and role B ends, right? So if you put that into like vendor context, we have sales teams that are going to become more like engineering conscious. So they'll actually be able to code more. They'll be able to demo more. I got our sales GM to do a demo of something very technical, and he did an insanely good job, like insanely good. And he actually showed you how this is what it used to look like when I did this on email as a cascade and disrupted everyone's Monday morning, versus I can ask these questions on a Sunday night and walk into work on a Monday and know the answers.
Yeah.
So that's a fundamental paradigm shift. And that's using our Talk to Your Data tool called Genie. If you then look at that diffusion, we see the same thing in our engineering functions. So you have product and engineer, and actually that's just going to mash into each other. And that's been happening for a while, where engineers are actually writing PRDs because they have greater accessibility and they can pull data and telemetry from what customers are doing and sort of generate that, and then build code. And then everyone's actually going to flip to QA.
And I think that engineerization already started, because I remember the first time I've seen a role called revenue engineer or RevOps. And that was, always in IT. We built a system for sales, but then sales started to incorporate some of the roles. And then some salespeople became more technical. And that was even before Claude Code and other agents. And they started to build their own tool. And so the technical role just mashed up with the sales role.
Yeah, so we had a similar thing happen actually in our finance department.
Yeah, I wanted to say the two.
So it was really a fascinating thing that happened, right? So as I said, IT is 2% of our headcount, okay? And we are a very engineering sort of minded company. And over in our finance department, we have incredibly clever finance controllers and, FP&A analysts and a variety of different roles in finance. And with a very small team, and this is the key thing that I've noticed, is that you can build unspeakably powerful software with incredibly small teams. Yeah. So I think we had a team of 2 in 2 months, and this is not a now thing, this is like a 18 months to 2 years ago thing, built a real-time revenue tracking engine. Yeah. Now, we're a consumption business, so we have a lot of log and telemetry data, so we could actually kind of, using our data in order to kind of leverage this, we have a data team that organizes it and governs it really well. Obviously, we use our own tech. And this team basically built a real-time revenue engine and a unified forecasting engine. 2 engineers, 2 months, I think it was. We see the same thing with like really hyper-performant business units in certain industries. So a good example is always pharmaceuticals. They always have really good engineers, scientifically minded system thinkers. So in the commercial department of one of our big customers, they basically built a tool, team of 2, I think it was 3 or 4 months, built a tool that basically reads 400,000 clinical trial documents, built an application, and serves it as a kind of helping function to all their medical reps. So the reason I always love that example is team of 2 to 3 months. It's evolving, which is super fascinating, which speaks to the dynamic software. And it's highly regulated content. And what we learned from that is how much time is spent building, far less than ever before. How much time is spent testing, far more time than ever before. How much time is spent orchestrating and evolving, far more time than ever before. And then running it is like a constant loop. Yeah. So we're already starting to see the early signs of like how this diffusion moves from IT into business units. So to your point, it used to be a kind of IT finance function, which then became a RevOps function. Now, the early signs of RevOps were very administrative, and then they started to move on to Excel and spreadsheets, and then now they're starting to use like vibe coding tools and Databricks as a kind of back end. And they still have a ledger. They still have like, a system of record.
Because you often just wrap the old stuff.
Because you often just wrap the old stuff. But they're building new functionality to basically make the finance function more performant, but they sit in the finance function.
Our head of finance, who is not a technical person, wrote an invoice tracking app because it took too much of his time. And when I saw it, I was shocked because you just don't expect something that 4 years ago would have took me probably 3 days. And he did it in, if I remember correctly, 4 hours. It was a script, but there was API calls, a UI, it was a dashboarding there. So it was fascinating because it showed me that, okay, so this is really a whole new thing that people start to build their own tooling now.
So I think it's representative of something much bigger if you think about operating models. So I've given you a bunch of examples. So let's go back to what that kind of means for the operating model. There's this kind of analogy of edge to the center, and this kind of feedback loop. So if you imagine your finance person, they get irritated with something they're trying to do because it's really painful. Finance people are actually incredibly analytical, and we don't always appreciate how analytical they are. We often kind of have this clear distinction between IT versus finance, but they're some of the most tech-savvy people I've ever met. Okay, sometimes they're a little bit kind of spreadsheet function focused, but they get irritated and they do quite remarkable things with rubbish tools.
Yeah.
Now we've given them a superpower, which is the ability to code without needing to learn how to build a whole bunch of Python libraries and kind of stitch things together. And they don't even have to really learn SQL. They just iterate. So they end up building very, very good prototypes that help them to do massive, challenging parts of their job, instead of relying on very generalized tech that serves the mean, not the person. You take that back to the center. Okay, so basically it's built on the edge. It's shipped to the center. We already have quite good means of doing this, although I think that will evolve again. So they teach them how to put it into Git.
Yeah.
And it then we've kind of done some of this teaching already with some of the version control you have in, the document repositories that people use. So we moved from file servers to document repositories. So this diffusion's been happening for quite a while to educate people on version control, to educate people on actual what repos. We never called it that, but it's a repo. Yeah. Dropbox was a repo.
We try to wrap things over that.
And imagine that then diffuses back to a ops team that productionizes it and makes it more hardened, and then diffuses it back out to the teams, and then it iterates. That is a very different feedback function of technical users who have a business function pushing back to a small, almost power technical function that is very good at productionizing, and then it just goes back around. And then there's almost this kind of monitoring piece that fits in there, like flight traffic control, where they're kind of just making sure that the behavior is good. Now, if you're rethinking your company, and you know that these are the changes that are happening because you can see what's happening with AI natives, you can see what's happening with digital natives, the knee-jerk reaction is fire half your people. That's the wrong move. Yeah. Now, why is that the wrong move? Because you haven't absorbed the gray matter of their job. So always the worst thing about losing high-quality people is the domain experience walks out the door, and that kind of goes. The coolest thing about this tech is that diffuses into your system. And if you figure out a way to harness that, it actually means the risk of losing someone goes down. The organization gets sort of far richer return for the human activity that they're paying money for. Okay. But this is going to happen over time because most companies don't have this data. They're not capturing this data. This data is locked there, or it's locked there, or it's locked there. It's there's lots of forms. Lock-in is not just about a system, a software company that happens to have data stuck in it. It's about code. It's about semantics. It's about gray matter of humans, domain knowledge, stuff like that. All of that stuff can actually diffuse. And this is why I think telemetry is the biggest thing that's going to happen. Trace that comes out of humans.
In just non-technical areas.
In non-technical areas. Yeah, okay. And I think there's caching. Caching is going to be huge. I don't know what to call it without sort of coming across as technical, but it's like the exhaust fumes of humans and AI working together that we gather.
It's like the digital trace of how an organization really works.
And I want to be very careful about using the word graph. Yeah. Because I think we always jump to an implementation. I think this is a totally different implementation.
Yeah.
And people jump to ontology, the amount of ontology conversations. Having a glossary of terms, understanding and being very clear about meaning, that's the first principle problem. Let's not jump to a solution. Yeah. Let's figure out what and this is the coolest thing about being a biologist is you look at emergence. What emerges out of the system? Bitter truth. What will this thing come up with when I tell it the problem? Rather than me being overly descriptive about it. And that's one of the best things about having software engineers coming out of business users is they have no clue all the shit that you've had to learn as a deep software engineer over time. So they just let it happen. It's kind of they lean into the bitter truth.
You mentioned the diffusion as one key point, and the other one is how organizations need to rethink how they operate? And what would you suggest? What should a data leader who cares about this happening in his or her organization, what should they do tomorrow?
Hack your job. And what I mean by that is it's kind of a fun thing. There's a famous Michael McIntyre skit. Michael McIntyre, for those who don't live in the UK, is one of the best comedians in the UK. He's hilarious. And he's got this skit about parenting. And he talks about there's people that know and then there's people that don't know. Okay. So when you become a parent, something existential changes in your life. So he uses the analogy of leaving the house. So when you're not a parent, leaving the house is a very simple thing to do. Like you look at your partner and you go, let's leave the house. You open the door, you leave the house. When you have small children, and I have 2, leaving the house, I actually this morning had to go back to the house 3 times. Okay. And it's the most frustrating thing in the world.
Yeah.
Right? So if you are talking about AI and you're not a power user using AI, you are not a data leader. Okay. You should be, I don't know whether you play on the weekends, or you just build stuff that something in your job will irritate you. Grab Claude Code and do what your finance person did and just build something that solves it. It might be throwaway. In fact, very likely it'll be throwaway. Yeah. Or it could be something relatively useful that you can ship to the center. So ship to the people that actually build stuff for a living and show it to them so that they can kind of do something with it. Data leaders that are sitting in meetings, playing politics, and not actually using this stuff are going to be found out as non-credible straight away. Because the biggest problem is some of the most credible users that I've met in boardrooms are like finance people using AI. They're HR people using AI. I actually sat with our EMEA HR manager and we sat down and did a whole AI piece. I'm doing the same thing with our comms and PR person. Like each of these people, I'm spending time with sales teams, and some of them are they're hungry to do this because they're just frustrated with waiting in a queue for someone technical to do something for them. I've got a very, very good friend who's a non-technical, hyper-tech savvy entrepreneur. And he is constantly looking for someone to build something for him. He doesn't have to do that anymore.
Yeah.
He has, over the last year, become one of the biggest super users I've ever seen. And it's just because, I don't know if it's just his motivation, his intrinsic motivation to just solve frustrating puzzle problems, scientific method. I would bet you money that some of the scientists are going to become some of the biggest power users. Engineers are going to be all over this like a rash. So I think this is going to diffuse faster than we realize. And data leaders that are culture's a big problem. But the first big problem is an intricate understanding of what we're dealing with and how quickly it changes. I built something in June. I rebuilt it last week. I'm not even kidding. In June, I was profoundly impressed. Last week, I was blown away. That's how quickly the difference is between the tech from June and the tech from today. It's fascinatingly useful. I don't do it all the time, but I do bursts to kind of recalibrate and know, okay, this has changed, this is what it means. This has changed, this is what it means. This has changed, this is what it means. And I obviously do a lot of roundtables. I do a lot of synthesizing feedback and things like that. I observe what people are doing. I think data leaders have to do that. I think if you're a chief AI officer, which is one of the most underappreciated, but also completely clueless, we don't know what it does role, I think that's good. I think not knowing what it does is probably the best thing ever.
Yeah, you have to know what you're dealing with to be able to make the change.
100%.
Yeah. Dael, thank you very much. I think this was full of really interesting takes. So thank you very much.
Thank you. I appreciate it, and really cool to hang out and talk to you today.
You too. Thank you.